Hello, welcome back to my Tech One. I have filament testing for this video, and these boxes are sent to me by the Sunlu in exchange for a review. Approximately a month ago, I got an email from the Sunlu if I want to test their new PLA META filament. I said okay, but the video is much more interesting if I will compare that with, let's say, PLA Plus, and I saw that they also have a carbon fiber version of the PLA. And I can compare with that too, because I have those regular test objects, so my results are comparable with those which I did earlier, but it is more interesting if I compare some filaments in the same video. Okay, there he sent me a package. And maybe a few weeks later, I got the package and I saw 3 boxes inside, and I already know which one is missing, but the one I was curious the most. But as you know, I have patrons, and all donations I am using for the equipment and material for this video. So I decided to buy this filament. So this is Sunlu's carbon fiber PLA, because this is the filament I am mostly curious about, and I want to include it in this video. And I believe this is then some kind of complete experiment. About these materials, unfortunately outside of the box we cannot see information what is inside, so I have to open the boxes to see what type of filament is inside. About PLA META, it's their new product, and according to the website they said it is strong and more fluid PLA. Probably with this they mean more viscosity, and it can be printed on lower temperatures. And also they said it is tougher and harder material, so remind me to include the hardness test in this video. And also it has improved impact resistance. But basically these properties, mechanical properties, are similar to PLA Plus, but PLA Plus has to be printed on higher temperatures, and we will compare it to the regular PLA. And of course I am very curious about the carbon fiber version. Don't forget, with carbon fibers you need some kind of hardened nozzle, because brass nozzle may be very quickly by those fibers inside. On the box outside there are no markings what is inside. These are wrote by me. Only on this it says PLA carbon fiber. But partly we can see inside, so this is black, yellow, some kind of grain, and of course carbon fiber is in black color. Let's see the spool inside. The spools are in nice vacuum packaging, and here I have only one sticker, information about what is inside, and only on the other side. But for example, there is no brand on it. I don't understand, Sunlu, why they don't put their brand on the spool. So it has PLA META, an interesting printing temperature between 180 and 200 degrees Celsius, very low. PLA Plus in yellow color, printing temperature between 210 and 235 degrees Celsius. So this means I cannot use the same G-code for these filaments. This is regular PLA between 200 and 230 degrees Celsius, recommended print temperature. And this is the carbon fiber version, 200 and 230 degrees Celsius, recommended printing temperature. And unfortunately for the video, not too interesting, so 3 of them are in black color and only 1 in a yellow. This is vacuum packaging, but the bag is not resealable, so we cannot place it back and close it after the printing. But anyway, the PLA is not so sensitive to moisture compared to the, PLA or nylon filaments. And it's very nice that they have the warning for the beginners to prevent the tangling, to lock the end of the filament. But Sunlu, for this I would recommend to place more holes on this spool. And the distance should be a little bit bigger, because I'm not sure is it visible on camera too, but for example in this case this already broke on these 2 spots. I think with carbon fiber version they should include here the warning about the hardened nozzle. Usually the carbon fiber version on the touch are like a sandpaper, but this is a little bit smoother, not like those carbon fiber nylons I tested recently. But of course it is not so smooth like other 3, but anyway definitely use a hardened nozzle with this carbon fiber filament. I'm starting with regular PLA, and the temperature tower will be from 230 to 200 degrees Celsius. The first layer looks good, but usually I don't even have problems with the NS3 S1 and PLA. Printing is okay, only I can see a little bit more stringing on 230 degrees Celsius, significantly reduced on 220, and completely disappeared on 210 degrees Celsius. But this means that the filament is not completely dry out of the box. Last element looks perfect. And if there would be no stringing on 230 degrees Celsius and minimally on 220, this could be a perfect temperature tower because it has great bridgings, perfect overhangs, and also all other surfaces are great. And this is the back side. All test subjects will be printed at once. After 1 hour and 25 minutes everything is okay, and I hope it will stay like that because this will be an overnight printing. Good morning, and the printing was finished without problems. I can see that stringing was presented even on this temperature, but very minimally. And now moving to PLA META because it is also in black color, and the temperature tower will be from 200 down to 280 degrees Celsius. I usually never print on so low temperatures. The first layer is okay. This is the bridging on the second element. And it's okay, there is no stringing at all and the bridging is perfect. I was worrying about printing on 180 degrees Celsius, but this looks okay. I cannot see any kind of the error on this temperature tower. Perfect bridging, overhangs, great surfaces, absolutely no stringing on any temperature. And now I print all test objects on 190 degrees Celsius, which is in the middle of the recommended printing range. For PLA META, we use the silver marker. Again, all test objects at once on 190 degrees Celsius, and this is great first two layers. Last two elements for the layer adhesion test. And now PLA Plus, and this yellow core will be a real refreshment for this video, and the temperature tower will be from 230 down to 210 degrees Celsius. And like with other PLA filaments, there is no problem with the first layer or the bed adhesion. This will be another very clean printing. Just few strings on maximal printing temperature, but otherwise this is another perfect temperature tower. And I don't have to mark this one because this is the only one which is not in the black color. And I print all test objects on 225 degrees Celsius, which is approximately in the middle of the recommended printing temperature range. Well, this is another perfect first layer. I can see a few strings here and there, but I'm not worried about it. And this will also be printed during the night without supervision. Override printing successful, and I can see just few strings, otherwise it is great printing. And it's time to print PLA carbon fiber, but there is a small problem. I checked on Sunlu's website very detailedly. I couldn't find any information that it requires hardened nozzle, but I'm sure that I shouldn't print with the brass nozzle, and I don't have hardened nozzle on NS3 S1. The only printer which I have with a solid hardened nozzle is the Prusa S behind me, so this will be the only filament in this test which will be printed on different printer. But I have no choice, I don't want to risk to print it on the brass nozzle. Currently the enclosure is mounted on this printer, but it will be open because it is not good to print PLA inside the enclosure. It's a little bit hard to see, but the first layer goes down perfectly. The printing looks great so far. Printing is finished, quick bed adhesion check. Okay. The skirt came down very easily, so probably the object will too when the bed cools down. Bed cooled down? Oh, perfect. I will compare all temperature towers later, but this is perfect. I think this one is the best. And for the filling, it is a little bit like a sandpaper, so I can feel those carbon fibers. Now I have to decide on which temperature I want to print the test objects. Now, the recommended printing temperature is between 200 and 230 degrees Celsius, same like with the regular PLA. But since here we have to use the hardened nozzle, but they don't mention it on the website, and probably with the hardened nozzle it has weaker thermal conductivity, so we have to raise a little bit the temperature by 5 or even sometimes 10 degrees Celsius. So I will print all test objects on 220 degrees Celsius, not in the middle on 215. Start of the printing is without problems. This is now the third layer. And last two objects for the layer adhesion test. And I think I have to reprint this one for the bending test. And here they are one more time, side by side. The first one is the regular PLA, then PLA META. The yellow is PLA Plus, and the last one is the carbon fiber version. And the same order here. And now everything is ready for the mechanical testing. A tensile pulling test. These test objects are printed in horizontal position, and I am starting with regular PLA. PLA META. PLA Plus. Carbon PLA. And this is how they broke, and when I see a break like this, so not on small cross-section area, this is typical sign of the weaker layer adhesion, but this was also weak in this tensile test too, so not too promising for the carbon version. And now the layer adhesion test with these vertically printed test objects. Smallest cross-section area is 4 by 4 millimeters. PLA META is the next one. PLA Plus. And the carbon PLA. Are these carbon fibers only for marketing purposes? Well, you saw the numbers, so these three PLAs are very strong, but the carbon version is very weak. But in all four cases, the cross-section areas are very similar. And now two-sided shear stress, and I'm starting with the regular PLA. And now PLA META. PLA Plus. And the carbon version. They all shared correctly on those two cross-section areas, only sometimes I cannot find all three pieces, especially if they are in black color. And now 3-point bending test. The distance between supports is 50 millimeters, and I will measure the deformation with this dial indicator, and I will place first 1.25, 2.5, 5 and 10 kilograms, and I will record the deformation after 1, 30 and 60 seconds. Only in video I will show you the deformation after 30 seconds. Here you can see side by side the PLA and the META PLA filaments. And now this is a 5 kilogram load on them, and this is the 10 kilogram load. And then moving to PLA Plus and the carbon PLA, and this is 2.5, 5 and 10 kilogram load after 30 seconds. Looks like this is not too big load for this object, because I cannot see any permanent deformation on them. And now my torque or twist test. I have this test object 6 mm in diameter, and this side goes into this torque meter and the other side goes into the vise, and I want to record the load at 90-degree rotation and the maximal load. Regular PLA. META. PLA Plus. Carbon. .7, and it's already broke. Well, these three broke very similarly, and the carbon version, well, you can see this delamination, and that's why it failed very early. With this IZOD impact tester, I have this half-kilogram hammer, and there will be the test object, and it will swing to the other side and break the test objects. It depends how much energy it will use for the breaking, it will swing to the other side, and if the material is tough, it will lose more energy and swing to the lower position. And with this I can measure how tough or brittle is this object. Regular PLA, 0 position, PLA META, PLA plus, carbon PLA. These three broke very similarly, they are very brittle materials, but the carbon fiber version didn't broke in the first hit, only when the hammer swing back, only then it broke off the remaining part. But now let's analyze the footage. The scale, and this is the 0 position of the hammer, and this is after breaking the PLA test object, and this is after breaking the META PLA, PLA plus, and carbon version. And if I measure everything from the 0 position, I will get the height for calculating of the potential energy, and I will use this equation. Half-kilogram hammer, g is the acceleration, and the h must be in meters, and I will get the energy in kilojoules per square meters. The graph I will show you in the results part. The creeplets will give us information about the deformation under the constant load. I have these test objects, and this is the reference surface, and I will place this 1.25 kilogram load on these test objects, and I will measure this distance every day. This is regular PLA, PLA META, PLA plus, and carbon fiber PLA. And now placing the load. And now measuring the reference surfaces, but I'm locking the position for more accurate measuring. 1465, 1480, 1505, 1440. And I will measure them every day, but off camera, only I will create a picture each day. This is day 0. Day 1 after 24 hours, day 2, day 3, day 4, and the last day 5. This is the last day, and now let's remove the load. And this is their deformation after approximately 10 minutes after I removed the load. So as you can see, the biggest permanent deformation we can see on the carbon fiber version, and the smallest I think on the PLA plus. And I'm not placing them in the oven during this grip test because last time when I tested PLA it fell down, so I don't want to damage the oven, but I will do my regular temperature test. I have these test objects with M10 nut as a small load, and I will follow the temperature of the first deformation with this cooking thermometer. This is just a backup solution. And this is the time lapse of approximately 5 minutes. Don't be confused, the backup thermometer has a small delay, more accurate is the cooking thermometer. And as expected, all 4 PLA filaments started with deformation on 50 degrees Celsius. Only I noticed that the further deformations had a different speed. I will stop the experiment now on 100 degrees Celsius because I want to see the condition of the carbon filament. For the filling equals of these 3, and this looks quite hard, and I can see less deformation on the carbon PLA. Well, they cool down now a little bit, so I can touch him, and as you can see for the filling, these two are very equal, and also the PLA plus. And for the filling, I cannot deform now anymore this carbon PLA. So in this test, the carbon PLA is the best. I almost forgot, and now let's measure the hardness with this short D durometer. And I'm measuring in the direction perpendicular to the layers. And this is the regular PLA. 74.5, 75, 76.5. META 79, 79.5. PLA plus 78.5, 70.5, 79.5. And now the carbon PLA 70, 71, 73.5. So looks like yes, the META is a little bit harder material compared to the others, but I'm not sure what it means. With metals it means it is more wear resistant. I'm not sure is it the case with the plastic too. And now let's analyze the data. I'm starting with the creep test. So these numbers are directly measured values between two reference surfaces. But what we need is difference between 2 days. So that's why I prepared this table, and this can be visible on this graph. And here we can see basically these are very similar. After third day, these are very minimal deformations. Only the carbon fiber PLA had a little bit more creeping even on the 5th day. Tensile and layer adhesion test. So these three filaments are very similar, and actually they perform very good even on the layer adhesion test. Only the carbon fiber PLA was very weak even in the layer adhesion test, but also in this tensile or pulling test. On this two-sided shear stress, as you can see, all four filaments perform very similarly in this test. And now that bending test, I think this is most valuable information. Here we can see only the deformations after 30 seconds, and this is what you can see in the video too. But I believe that more useful information is this. So as you can see, I record the deformation after 1, 30 and 60 seconds. And let's see, if I analyze this should be something horizontally, then it is good. If we have something under the angle, like I think here, that means it creeps and the deformation is presented even after 1 minute. Smaller values are of course better, so in this test the regular PLA performed the best. The torque or twist test, again, these three filaments are very similar. Maybe the PLA plus was a little bit stronger. And thanks to that very weak layer adhesion, the carbon fiber PLA was very weak in this test too. The IZOD impact test, here I measured the breaking energy, and interesting, so here the PLA plus was the best, and then the other C filaments were very similar. The temperature tests were basically with PLA don't affect too much, so they deform approximately at 50 degrees Celsius. And since they measure the hardness in the specifications, I measure it. So yes, the PLA and PLA plus basically they have a little bit bigger hardness on short D scale, but I'm not sure how important is this. Maybe they are a little bit more wear resistant filaments. And now the conclusions. Well, you saw the numbers about first three filaments, the PLA, META and PLA plus. They're very similar materials. It is very nice that META can be printed on lower temperatures. This may be important for somebody with those cheaper printers, which are not able to print on higher temperatures. But still from these three, I think the PLA plus is my favorite, especially because of that impact test. So it's a more tough material. About this carbon PLA, if we watch only the mechanical properties, it is a very bad material. But recently I got some carbon fiber ASA for testing, and the manufacturer clearly informed me about its biggest advantage. Is in electricity. It has bigger resistance, and it will not electrocharging or something like that. So maybe that's the case here, but on Sunlu's website there are no informations about this. So I think the Sunlu should work a little bit on those background informations for the users. And also I think they should add at least a logo on their spools, and Sunlu add some little bit more holes for the locking end of the filaments on the spool. Results for these four filaments you can download from my techfan.com website. And for my Patreon supporters, this is my only gift to them basically. I'm adding these results to that summary table so they can compare to my earlier or future results. And basically, so every viewer have access to each result separately, one by one. For my Patreon supporters, I am saving them some time and they have access to that summary table. That's my only gift to them. If you have some additional experience with the Sunlu filaments, write me full lines in the comment section. Thank you for watching and happy printing!